if I look at number 1, and I try to solve it like we did yesterday, so if I set this equal to x, and I do 6 to the x power equals 39, which is the left, right, middle. So we're moving it from log form to exponential form. And then our goal is to find an answer. So, okay, if I put in 2 here, 6 squared is 36. It's not 39. If I put a 3, it's going to be 216. So this is not clean at all. So I'm not able to actually use this way just because of the way the setup is. So there's got to be something else and another way we can solve it. And this is what we need to do. So go to the very top. And if I ever have a log with any base b of a particular, we'll say a, to solve this, I can actually use common logs. So I can use common logs to solve this. So I can actually just do log, which is base 10 of a, divided by log of b, which is the base. And the easiest way to remember that is the base goes on the bottom. The base goes on the bottom. So any log in this form, you can do this and solve. So if I look at number 1, right, and I use the change of base formula, then I would put log of 39 on top, and then log of 6 on the bottom, okay? Log 39 on top, log 6 on the bottom. This is a decimal. I'm going to round it 4 places out. So this will be 2.0447. Okay, so this one, if I take and I do log 1.9 over log 5, right? So base, again, always on the bottom. And I'll show you what I have rounded this to in a second. So in order to solve here, we're going to do exactly what we did yesterday. I'm going to take it, and I'm going to do left, right, middle. So 3 to the 5th power equals x. So 3 to the 5th power equals x. And again, left, right, middle. 3 to the 5th power equals x. And now if I want to solve for this, all I have to do is do 3 to the 5th power. What is 3 to the 5th power? 243. So number 3, same thing, left, right, middle. So if I do left, it's 2. So base 2 to the 7th power. 2 to the 7th power equals x. X would be 2 to the 7th, which is 128. Okay. If it is in log form and you're solving, your goal is to get rid of the log somehow. In example 1 and 3, we are converting it into exponential form to get rid of the log and solve. I have one log on the left and I have one log on the right. So if this is the case, I can mark out the logs and set 10 minus 4x equal to 10 minus 3x. That is all I need to do. And then solve it. So you're taking it from something that looks extremely weird and strange with the logarithms, and you're taking it into something you can actually solve. So let's color code it. I'm going to add 4x, add 4x. I'm going to subtract 10, subtract 10. 10 minus 10 is 0. Negative 3 plus 4 is x, so that means x equals what? X equals 0. Number 7, even though it's natural log, I still have a natural log on the left and one natural log on the right, so then I cancel, and then I simply take what I have and then solve for it. So I would add 5 to 4 to make 9. I would add the 2 over here to make 7, and then this would be p equals 7 over 9. Yes, it's an ugly answer, but that's the answer. So in this example, I have log base 2, parentheses, so of 5x plus 3, and then equals 3. So in this example, I'm going to go 2 to the 3rd power. 2 to the 3rd power equals the middle, so left, right, middle. Then I can go 2 to the third power, which is 8. Subtract 3. 8 minus 3 is 5. And then 5 divided by 5 is 1.